it.
Okay. Yeah, let me share my screen. Yeah, if it's okay.
Yeah, I'll stay on until the screen shared so I can tell you if everything's good.
Okay, yes, I'm doing my screen sharing now.
Yeah.
Okay, yeah,
Awesome.
today I talk about the application of RT Trade in IIoT. Yeah, thank you for introducing about me. Yeah, like what you mentioned, I have a company that involved in software development, doing web application, mobile apps, and also embedded system that goes along with it. And today I talk more about the industrial IoT based on projects that I have been doing. Other than that, we also do some e-commerce, and we have been using cloud from provider like Huawei, and we are like their partners. So these are actually relevant in things that we need to use in achieving industrial IoT. Yeah, okay, so this is basically just my abstract. So I just put it up over here so that roughly today I will cover some of the industrial IoT projects that we achieve using microcontroller. Where we have found that by using RT thread, it actually gives us like a Lego alike building blocks that we actually can use different components for different projects. There are many libraries that is usable, and we can actually change the microcontroller as long as they support RT thread. So let's directly just go into components of the industrial IoT. Yeah. So before that, let's look at a typical IoT application. Yeah. Okay. So the IoT application basically just means there is a IoT device. It can be a mobile phone like iPhone, Android, Huawei phone, and also it can be a IoT devices that are sensor, basically an embedded system. They sensor that actually connect to a cloud. Like from Microsoft Azure or Cloud, where we actually implement a server on the cloud and database. So in this case, I give the example of using the Postgres QL database. And we typically also use like the ECS and database servers on the cloud. So in the context of in my country, in Malaysia, typically I can achieve this with a cost of RM 700 ringgit per month. Typically, we use .NET for my team. So what this backend software typically do, like in this example, we actually have a different people can log in at the time to provide update on the production process. So this is a typical IoT application where we actually need to program the device that actually send data to the cloud, and the client software can again integrate to the cloud to get data from the cloud. This is the application. Yeah. So in terms of the actual components that we use, these are the blocks. Right? On this side, we actually have the mobile device and also the IoT device. Like I mentioned, we use the .NET programmings, and we subscribe to the infrastructure as a service provided by the cloud provider, be it Alibaba Cloud, Huawei Cloud, or Microsoft Azure or Amazon, where we actually can host our server there so that we can run our backend. Then we definitely need to use a PC for development. So let's look at one example. When it goes down to embedded system development for IoT. So in this example, we have the microcontroller running RT thread over here. If you can see my mouse. So it is running a RT thread, and this microcontroller, it will sit inside outdoor casing. Typically for industrial IoT projects, we typically may have to put it in a harsh environment, be it outdoor or it's inside a factory where the whole thing need to be protected from the outside elements we can kill the electronics. So we typically have a casing like this. So inside the casing, we have a few components. In this case, we actually have the power supply and also the battery that keeps the system running, even if there is a temporary power down from the external power. And because it's a IIoT, industrial IoT or IoT projects, we need to connect to the cloud, like in my few slide in front. So we typically have a 4G DTU, which is over here to send the data to the cloud. Later on, I will talk about all the I/O that we needed for the to interface to external sensor, which is like the one that I show over here. In this case, I just show a few different sensors because this particular project we are doing outdoor temperatures and raining and flood monitoring. So we use this type of sensors to interface to the HMI board. So in this case, it's just a rain tipping bucket, PM 2.5 sensor, and some water level sensor. So typically, all these sensors, they have interface that cannot be directly interfaced to a HMI board, and we basically interface it to a I/O card instead. So I explained that. Yeah. So in this particular case, we also interface to a energy monitoring device, which is monitoring the three-phase power used by all these box. So again, when we actually have the data, we can send it to the back end through the 4G. And by using the RT thread, because of the many libraries that is available, we actually can cut short our development time very short because we can reuse most of the function blocks that we have done in previous project. And typically a project like this, we can finish in about 8 weeks, 2 months, less than 2 months. And we actually have the clients like mobile apps or the internet client browser base that can interact with our software. So let's look at how it runs. Right. So I'm going to show you in the next screen. Right. So we typically have the backend that have a user interface that look like this, where the sensor is sending data, and then the operator can actually look at the data presented by the IIoT hardware on the PC. So let's look at this in real. Okay, when it's sharing screen, I had to see where is my page. Yeah, okay. Let's see, where's my page? Okay, let me close it. Sorry about this. Couldn't see my page. Let me close this. I lost my page. Okay, let me go back to here. I save it nonetheless. Okay, yeah, it's here. It's blocking. Okay, so you can see that right now, I actually have 2 of these sensors currently running real time. And they are sending data. They keep sending data. You see the time, the clock is clicking, and we are actually sending the sensor data, which is the water depth. Right now, because we have 2 water depth sensor, one is at 8 meter, another is at 0.51 meter. And we typically also have the GPS coordinate of where our sensor is. And then we can also, in this case, we can also edit the threshold that actually will send off an alarm when we actually when the sensor is over. So let's look at this value. You can roughly remember 0.52, and we can then look at the program that is actually currently running remotely. I actually show the RT Thread Studio. where we actually have the sensor running, where you can see that it is keep on sending data. In this case, you can see that it's actually sending 8.01, if you can see, and 0.51. So it keeps sending data, and it also send the GPS data. And this data is the one that actually goes into the back end and we presented in a dashboard. Yeah, so that's how IIoT software looks like. Okay, let me go back to the slide. Let's go back to the slide. Yeah, so just now, this is actually the actual setup I have in my office, where I actually dip the sensor in the water. There are a few couple sensors that we actually connected to it. So, but let's talk about the sensor interface. So in IoT project, we use industrial type of sensor. So all sensor will have interface like analog input, digital output, and analog output, or Ethernet, Wi-Fi, or RS485. So we typically cannot connect many of the sensors directly to the microcontroller that is supported by RT-Thread. So I will show you how we achieve that. For example, in analog input, typically we have 4 to 20 milliamp or 0 to 10 volt input. Whereas in the microcontroller, they only typically run up to 5 volt IO. Yeah, so this is how we deal with it. So let's look at the analog input. So in this case, the water depth sensor is actually having analog output 4 to 20 milliamp. So, and the microcontroller typically have to get all this data through a two-stage conversion. First, we actually convert the 4 to 20 milliamp by using this off-the-shelf converter. That's actually converting the 4 to 20 milliamp to RS485. So with the, after that, we have another converter, RS485 to UART, and connect to the RT-Thread. So this type of converter is readily available. For example, this is what you can see available on a local e-store. Yeah, so you can just buy this thing and connect to the microcontroller. So in this particular case, the HMI board UART is communicating with this module. So with this, we actually can have analog input supporting 4 to 20 milliamp, which most industrial sensor is having. The other way around, if we use an output module, the 4 to 20 milliamp output module, we can also send 4 to 20 milliamp output, yeah, as actuator. In here, I did not show that an example. Yeah. So now let's look at why we are using RT-Thread, because it actually gives us a very useful and free RT-Thread Studio for the community edition that actually let us able to select board and also select the library that we want to use. This shows the RT-Thread Studio, and in this particular case, for the project that I showed just now, there are a couple of packages or library that is useful. Like we have the RS485 where we actually use the Modbus library. We also use the JSON and LVGL for the display and the web client. So let's take a look at some of these, right? So for example, in MQTT, which is commonly used in IoT, the payload, for example, in this screenshot, you see that there is T current, H current, will need to be packaged in a JSON package that look like this. Before we send to the backend that actually can take the MQTT packet in JSON format. So RT-Thread actually have some free library, in this case like CJSON, that we actually can use, and it actually can package all this data for us. So if we look at the library, you can see that inside our project, we will see all this library inside the package that we use. Okay, other library that is useful in achieving IIoT is like the MQTT. And also one of the library that we use is actually the OTA downloader that provide over-the-air firmware upgrade. So why is this important? Is for imagine we have few hundred of all these sensor box, right? All these sensor box located in a different part of the city. So every time we want to implement firmware changes, we either have to go on site to program them, or if the sensor or the microcontroller have an OTA capability, just like our handphone, we can use an online firmware upgrade to upgrade firmware. So this is actually very useful library in IIoT. Yeah. So the last thing that I mentioned is that probably this is more like my wish list. In other industrial IoT or factory IoT projects, I also need to interface to test and measurement device like oscilloscope, function generator. So they typically use other bus protocol. Like if they are using USB, they might need USB TMC, or they actually use Ethernet for test and measurement device. So this like my wish list. I wish the Artitrack also will have this library implemented going forward, so that I can probably share about how to use this in the future. So with this, we come to the end of my presentation. Thank you.
Well, thank you so much. That was very interesting indeed. In fact, I was just looking at your website and seeing all the services you offer. So does anyone have any questions at all for Dr. Leo? If so, this is the time to post